Welcome back, Mr. Zhou.
Welcome back, Arthur.
How are you doing? All good?
Yeah. How was your session last week?
Last week, I think I didn't do any session actually. Yeah,
Okay, I
quite a lot
thought
of
you
teaching.
had yourself without me. I was like
So,
feeling, oh, you didn't do it with me.
FOMO, no? FOMO is always good. FOMO is very healthy. Yes. So today we're gonna change the format a little bit. We're gonna discuss the MCP. So it's the Model Context Protocol. Maybe I just give a small introduction, and then we can also discuss as we go. No, obviously.
Nice. So you're like teaching me a lesson again?
I'll do my
I'm your
best.
student again?
I'm doing my best,
Okay,
but don't expect too much, please.
nice. My
Uh,
expectation is always high when you're
it's
like
it's always high,
doing a lecture.
exactly. Yeah,
Yeah,
you're keeping me awake. Very good. I need to be focused then.
cool.
So the reason that MCP actually exists is because we want to enable the secure and interoperability among different AI agents, right? So an LLM can act as an agent if it can continuously be prompted, for example. And so why do we actually need this? Why what are the actual problems that we are experiencing nowadays? Well, one of the challenges that we face is that AI models are isolated. So for example, if you have an LLM1 like ChatGPT, it cannot directly talk to an LLM2 like Claude AI or Grok. So they really operate in isolated environments. You can really think of it as isolated databases. And it's really quite similar actually to how blockchains operate, right? So they're quite isolated. They don't have the ability to communicate with the external world. And so far there were actually quite limited standardization efforts for context sharing between LLMs and between LLMs and data sources. And the one way of, for example, having OpenAI as ChatGPT browse the web. I mean, OpenAI just implemented their custom solution, but then that custom solution wasn't the one that, for example, Claude used or Grok used, right? So everybody was kind of like doing their own thing. It's as if you have like multiple different USB standards, and you just can't plug the cables together, right? So it's really like not very useful in essence. And why do we need to plug things together? Well, the internet is really just a network of connected computers. So similarly, AIs, we want to connect them, right? In particular, we want to connect LLMs with financial data, weather information. We want them to be able to use the browser. We want to give them access to database, to clean up our hard disk that's full of too much data that should be deleted anyways. So that's really the challenge that we have. And Anthropic, so the creators of Claude, they came about and they created something that's called the Model Context Protocol. So the word context, I guess, comes from the idea that models may forget data and or may just not have access to certain data, and that's why they want to have a specific protocol that enables models to retrieve data. And so the MCP really enables the following things, right? It allows an LLM to access resources. So, for example, the LLM can trigger API requests and pass then the API responses. The LLMs they can call functions, so they can use tools. So, for example, they could use the command line, so Bash, for example, under Unix operating systems, in order to invoke, for example, create a directory, delete a file, touch a file, etc. And similarly, you could also have task templates to have specialized prompts. So if I were to actually quote Greg Eisenberg from X, he essentially said, well, a model context protocol is really it's like a USB-C port for AI applications, right? So now suddenly all these LLMs, they have the USB-C port. It took a while to switch from Lightning to USB-C, but we are now there, and everyone can talk to each other, right? So which is cool. So it really enables new things. It lowers friction to make the LLMs grasp context and also communicate. So what's the architecture, right? How does this actually work? Now, I've took the liberty to use the USB-C symbol here, right, as an icon for the MCP server. So the MCP server, if you want, is the glue between, for example, an MCP client, right, where you also have your LLM, and a database, right? So that's really like the gluing element that can merge them together, right? Um, yeah, Lee, what do you think about this very basic architecture? Any comments so far?
Yeah, I actually have a fundamental question. Do you think this is the right solution? Actually, I feel like we are more like treating large language models as applications, right? I mean, we need this like common like interface because it's the application. But if you like let's say in the future, right, large language models may become like for me, right, for a human being, when I try to access information, I just like access different browsers and look up information. I can digest the information myself, no matter in what format it is, right? But here we need a common format. Do you think this is like a more like a short-term solution? I mean, an alternative I can see is you just give an entire VM to a large language model, and you let it like just open the browser itself, do search in the browser. If it wants to access database, sure. I mean, like just like open up your terminal, use some PSQL command to connect to your database in terminal, and then run some SQL queries, right, to fetch data. That's the alternative.
Right, by VM you mean just the give access to the LLM to a virtual machine, right?
Yeah, like
But
operating system, right?
yeah, but I think the question is like, how do you do this, right? Like, how do you define the interface between the LLM and the virtual machine or browser or whatever, right? And I think this is exactly what the MCP server wants to do.
But do we need a common interface? Like, for example, ChatGPT can have their own version of, like just how to access this VM. Cloud can have another version. I mean, I guess we want to have this MCP because we want to kind of like let anyone to code any application in this standard format for large language models to digest, right, to use. But the alternative is just grant large language model the power to use this operating system itself, right? And then we don't need any common interface.
Well, the question, do we need something, is a great question, right? And I think we
You
joked.
have
We did joke before that we should really finally create a conference that just accepts paper with the title, with the prefix "Do you need dot dot dot?" Right? So um, it's a good question. So if I were to ask, do you need a USB-C port on my computer, on my desktop, on my server? I would say absolutely, right? It simplifies my
Mhm.
life. I have it on my phone too. I can charge both my laptop and my phone with the same cable. They can exchange data on the order of, I don't know, gigabits, 40 to 240 gigabits per second, depending on, I guess, I don't know what's the throughput of Thunderbolt 5, but okay, whatever. So you have this standard, right? It essentially removes friction to interconnect components.
Mhm.
I don't feel it's a bad thing to have such a
Mhm.
so something I'm actually not having in the slides at the moment is just the sheer number of services that have jumped on MCP recently, right? Superbase actually announced, I think today, that they have now an MCP server. Stripe was one of the very first companies that had an MCP server. Anthropic was the one who actually created this standard, and then suddenly everybody's adopting it, which, to be honest, is fantastic, right? So, but yeah, I think there's a question whether we need it. I think the idea is really that you have here a set of servers, right? Where you don't just have a single one, but your agent and your MCP client here can talk to any of these MCP servers and then fetch the weather, look at the finance data, write or read into some databases, right? So I think that's really the overall idea, right? To have a more interconnected system, especially if we're moving forward, and as we are already with autonomous agents, right? That can just do tasks for you on an ongoing basis.
Right. I mean, probably it's a dummy question, but I mean, in the short term, I agree with you. I see value in the short term, right? Because it's just like making things like more convenient. But in the long term, I'm not too sure if this is necessary. Like right after like 5 years or something, given the agent will be like so powerful, it can do tasks itself, right? Without any hiccups, right? And probably there's no need to have a common interface. Look, when I'm using the internet nowadays, I do not have a common interface for me, right? I just do whatever, I can digest whatever data in any format.
I think I
Or
would like
not?
to question that. So
No.
you're, yeah. I mean,
You're
as a
questioning my
human,
capability? No.
no. I'm questioning whether there is no interface. I think there is a very specific human interface that's designed for humans, which is just the visual representation of how a website looks like, right? Which is encoded in some programming language. But essentially, we format data in a way that it gets digestible for humans, right? Specifically for human vision. Now, that representation may not be the best for AIs to observe, right? They struggle a lot, like extracting data from, I don't know, images at the beginning, from text without OCR, right? I mean, nowadays they're great at these tasks, obviously, but we humans, we can absorb so much data by just looking at an image, right? Whereas if we were to just represent the data as a JSON, the AI would be much faster than us, right? And we would struggle to dissect the JSON unless we 3D print it, etc. Right? So,
Right.
um, I think you like going on websites that do 3D printing, right?
Yeah, not a good practice, yeah, but
Okay, so just a small tangent here. Yeah. Yeah, so this is roughly the interface. I mean, I still like to give you credit, because I'm also not entirely sure how long lived this will be, right? But it has caught up quite a lot recently, at least. I don't have quantitative numbers, unfortunately, but yeah, I was just thinking whether maybe this protocol is also somewhat of a heuristic that we are implementing so that we facilitate communication. But I also don't think it's really a heuristic. It's probably really just a like an interface definition, or like a way to do interfaces. We will go actually into a concrete example in a bit, right? Actually, we will look at a very concrete use case, which is fetching the weather, right? In today's use case, I'll actually follow the quick start example from Anthropic. So Anthropic created this website as modelcontextprotocol.io. Essentially, you can go on this website. It's a tutorial on how to implement your own MCP server. It's a very simple one. And the client in this context of this tutorial is the Claude desktop application, right? So I assume you have already installed the Claude desktop application on your machine. I assume that you have authenticated with Anthropic, so that's kind of like already done on your machine. Now, the missing part is this MCP server. So this is in the middle here, which we will try to have a look at how to implement this. And this MCP server will allow the LLM to fetch weather data. And specifically, we'll be using the API provided by the website weather.gov, right? So that's the backend API that we'll be using. And you can think of extending this to anything you really want, right? Like, as we've mentioned earlier, financial data, databases, your file system, etc. So the goal, right, just to give you also like why, to give you a bit of a motivation of why we're doing this, the goal is to be able to do the following here. So you want in Claude, right, you want to query what's the weather, for example, in Sacramento, right? It's a natural language description of what is Sacramento. And then the LLM will actually understand your prompt. It will say, let me check the current weather in Sacramento, California. So it already narrowed down the query a little bit from Sacramento to a specific city in a given country. And here you can see the LLM then chooses to select one or multiple MCP servers that it may trigger functions at, right? In the specific example, the LLM, Claude, 3.5 Sonnet, decided to call get weather. That's a specific tool, right, from the MCP server weather, which is installed locally, which is running locally, and we will go through the details. And then essentially you can think of the API, right? The weather.gov API is essentially returning data which then the LLM can format in a given form, in a given presentation here, so that we humans can then read that data, right? So this is roughly the kind of the result that we're aiming for. So for the use case weather, there are two tools that we will be implementing. The first one is get alerts, and the input to this function is the state. So it's in this specific example, it's the US state identified by two letters. So for example, NY, or California is CA. And we can also get the forecast, and here we need to provide the GeoIP information, so latitude and longitude of the specific location that we want to have a weather forecast for, right? So just two tools. Keep it simple. Any questions so far, Lee? Okay.
Yeah, it's all clear. I guess you will explain like how large language models pick which tool to use, right? Later.
That actually I don't know.
Oh, okay,
Yeah.
it's a black box. Okay.
If you can find out, that would be actually great. Yeah.
What if like there's like thousands, like even millions of like tools, right? Because it's like anyone can do a tool, and then how do you? I mean, it's a bit similar to like this blockchain Oracle thing as well. You don't know where to find trustable like sources, and also how do you rank which one to query first or trust more, right? Based on the
Absolutely.
list.
Yeah,
Yeah.
it's quite unclear. Yeah. But okay. I mean, maybe you can check it out if you find some answers. But and we can discuss later. I do not know how the LLM. I mean, it's kind of like, I think it goes back to the question. I mean, there must be some prompt that prompts the LLM saying, "Here, I have this user request. I have these different tools available. Which one should I pick?" And then it needs to select one of them. And then why it did select one of them, that's essentially you asking me how to explain the interpretability of a model, which is quite a deep topic, right, in itself.
I guess
Yeah.
like naming is quite important here.
Exactly.
I mean, if you pick
So
a very sexy name, then
naming or domain names, right? Domain names
yeah.
are the interface for humans to select a tool, right? To select a website. Naming in the MCP world is essentially is probably similarly important actually for the AIs to pick the right tools. Before we implement the server, however, we need to first set up the environment, right? For this, we're in this example in the Claude tutorial, we're using UV, so you can install it, for example, with this command. Then we're creating a weather folder, a weather report, a weather project. We create a virtual environment, which I recommend highly, so that you don't get any conflicts with dependencies later on. We install the dependency. For example, in this case, it's the following here. And then we just create an empty file, weather.py, right? So this is just a setup of the environment. What we then do is to actually implement the server. So here it's where it starts to get a bit more interesting. We actually using fast MCP. So fast MCP, you can also see here at the bottom, is actually a very Pythonic way of implementing the MCP server. It became now also the official MCP server implementation standard, as far as I know. So it has been adopted in the Python SDK of the Model Context Protocol, which you can see at the bottom. I refer the link to that as well. So what we're doing is we're first creating an MCP server, right? So it's MCP equals to fast MCP, and we're just giving it the name weather. As you said, this name is probably relevant, right? If we have two with the same name, I'm actually not sure what's going to happen. So that's definitely some exercise that you guys can try out by yourself. And then what we're doing, we're defining two constants. So the first one is the API base. That's essentially the weather server API that we want to query, right? Which I mentioned earlier is the weather.gov website. We're defining also a custom user agent. This in this case is weather app. Like typically when you browse the web, this is, for example, Mozilla. But in this case, here we're just being explicit to the server that we're being explicit that this is the user agent of the server, right? In the case of this MCP server. Okay, now before we go into the actual implementation of the two tools that I mentioned, which will come in the next slide, we need to have a helper function in order to query the API service, right? So it's a little bit of Python code here. It's nothing too fancy. It's essentially just if you just want to look at the gist of it, it's an asynchronous client. So it's a non-blocking client, which here will actually create a GET request, right? So add a given URL with a given header with a given timeout. And what we will do is just to create this this request and then return the response in a JSON style, right? So that's really just the function make NWS request, right? And once we have a response, we also define a helper function in order to format, for example, an alert feature into a readable string, right? So this is again where we're trying to, for example, define, okay, we're going to extract the event from the alert. We're going to extract the area, the severity, the description that is given back by the API, and the instruction, right? If any of these elements are empty, then we either say it's unknown here, as you can see, or that no description or instructions are provided. So this actually has not much to do with MCP. It's really just two helper function. The first one in order to make the actual web request to the API, the weather API in this case, and the second one is to actually format the data. In a bit nicer way from that we get back from the API. All right, and well, now we are already here, right? Now we're going to implement the get alerts tool. As I mentioned earlier, right, this is getting the weather for alerts of a given US state. So the argument that we're passing, right, the state argument here, this is a string, as you see, and it must be a 2-letter US state code. So why should it be a 2-letter US state code? Well, it's because the API that we're using, right, weather.gov, api.weather.gov, is requiring to have these two letters. That's essentially their requirement. Now, you may remember we defined the API base, which is api.gov, api.weather.gov. If we want to specifically query the alerts of a given US state, we need to append to this base API /alerts/active/area, and here we have the two letters to designate a US state. Now we are getting data and by calling our helper function that we just defined in the previous slide. So that's the make NWS request on that given URL, right? The URL has all the information that the API then needs to actually reply to us because it knows which states we query the alerts at. And then we have two functions to just check if we actually got some results. So this is whether there's no data or if there's no features in the data. And if there's features in the data, we extract the features, right? So here we essentially extract the feature, the alerts, by formatting the feature, right? And then we join everything into one string for Python, and this is then what the function getAlerts returns. Okay. Any questions here or any comments, Lee, from you? Any observations?
It's fairly basic. I guess you just like for the last part when you join the alerts, it's just one way to implement things, right? The dash. There's no like a special meaning or
no special meaning. I mean, this is. I think this example could even be quite simplified, right? I guess, but it's. I guess Claude or Anthropic they wanted to make it a bit more fancy here, but we could definitely make it even simpler, right? If we wanted to. Cool. So the second tool, right? Remember, we have two tools: get alerts and get forecast. The second tool implementation is here. So it's a little bit longer, but not much longer. So essentially, the arguments that we pass to the get forecast functions are two floating point numbers. They correspond to the latitude and the longitude. So that's the GeoIP information at which we want to have a weather forecast. So weather forecast for a given location. So similarly, actually, we're creating here first a points URL. We again take the base /points. That's the URL. Essentially, this is predefined by the api.weather.gov website, right? So it's nothing we can actually change. We just have to abide by this. And then we pass here the latitude and the longitude in the URL. Then we make the web request with our helper function, and we check whether we get a return. If we get a return, then we extract the forecast URL. Again, this is something we have to do in order to be compliant with the API that we're using in the backend. And here we're gonna extract the forecast of the forecast of a given points data array, right? So first we check the properties and then the forecast keyword here. Again, we do make a web request and we check whether the forecast data was returned. If the forecast data was returned, then we extract the periods of this returned data, because there could be multiple periods. We then iterate over only the first 5 periods, right? That's just a custom choice that we here have. Obviously, this could be changed if we like to, right? And then what we do afterwards is really just trying to pretty format, right? So all this syntax is actually, it looks a bit more fancy than it has to. It's all just string and array manipulations, right? And nested array manipulations. So you can maybe simplify it, right? You don't have to print it in such a pretty format, but that's just what we choose in this particular example. Again, the join at the end is done as such, right? So you could ask, okay, why are we doing here 2 requests, right, to the API? It's just how the API works, right? We first have to get here the points data, and then with the forecast URL, we can then get the forecast data. That's just how the API at the backend works, and that's why we have to abide by the standard, right? There's nothing fancy or special about this at all. Yeah. Liyi, any comments?
No, I got some comments, but I can ask later. Yeah.
Okay, cool. So that's it. We actually implemented the entire MCP server. Now we have to run it. So to my understanding, there are 2 ways to actually run an MCP server. You can either transport the output of the MCP server over the standard input output, so STDIO, or over SSE. I think SSE stands for some connection where you can actually have authentication too. So in this example here, we're doing STDIO because it's the simplest. And remember, we installed UV at the beginning, so we can just type UV run weather in our weather MCP server folder, and that's really it. Then our MCP server at this stage is running. Now, if you want to use the MCP server in the Claude desktop app, right, you need to change the Claude desktop configuration. So here I'm actually giving you this is the configuration that you could use. So essentially you have the Claude desktop configuration file in the for example, on macOS, it's in the library, in the applications data of the desktop app, of the Claude desktop app. And there you will find a JSON file where you can put in MCP servers. So you can have multiple MCP servers. Here we have a given a single MCP server with the name weather. That's also what we defined at the very beginning, right, in the slides. And we tell actually Claude here how to run the server. So we will not manually run it with UV as in the previous slide. We actually let Claude execute the MCP server, right, to run it. And you can see Claude will essentially just use UV as we did. It will use a directory here. I had to actually pass the absolute folder, so the relative path didn't work. That's just a minor detail. And then run. So it's like essentially UV run weather pi, just like in the previous slide. If you then open the Claude app, your desktop app, and you will see here this little builder sign, then you know, okay, cool. I have an MCP server running. But Liyi, why is here number 2?
Yeah, that's also my question. No? Why is that number 2 here?
Okay, let me answer that question. Thank you for the segue.
Oh, okay. I see now.
It's essentially because we have one MCP server, but we have multiple tools, right? We implemented 2 tools. And if you click on this, actually, Claude will tell you these 2 tools are both from the weather MCP server. Okay, so yeah, this is so basically you're ready now to use it, right? And essentially, if you query it, so if we were to write now, what's the weather in Sacramento, right, you will essentially see a similar result to this one, right? That's all it takes to implement an MCP server that's called weather, and that runs locally, right? That is triggered by Cloud Desktop. So to recap, right? I think that's quite important, right? To recap, and it also goes back to your question, Lee. So when you ask a question, when you ask Claude a question in your Claude Desktop app, right? Then the client, right, which is the MC the your LLM client, right, sends this question to the LLM Claude, right? Then Claude, which is an LLM, has to parse your prompt. It needs to somehow find an answer to your prompt. And Claude, in addition to your prompt, right, knows which available tools it has. So Claude analyzes the available tools based on your prompt and needs to decide now which ones to use. Right? If you can have multiple tools, obviously. We have two in our example. Then the third step is the client, right? This is then the LLM client executes the chosen tools through the MCP server, right? And the results are then sent back to the Claude LLM. So that's actually what we as users, we don't directly see it, right? Unless we click like we view the details, view the results. What Claude then does, it formulates just a natural language response, right? Because we have a chat model that we're talking to, so we want it to formulate a nice response, and then it displays this to us, and we can read essentially what's the weather, for example, in Sacramento. Right? So these are the steps from my understanding how this entire thing works. Okay, we have one more thing that we want to discuss on this end. That's the so-called MCP inspector. That's another app you can install with npx. It's add model context protocol /inspector, right? If you run it here, for example, as such, you can start the MCP inspector. It's running at a given port here on localhost 6274, and you can then point your browser towards this IP and port. Once you do that, you essentially find a user interface as such. This is the MCP inspector with a given version. You may remember the transport type. We specified earlier STDO, not SSE. And you can then connect to this MCP server. So if you hit connect, that's how the screen then changes, right? So here you can also disconnect afterwards. And once you go to the list of tools, here you can click, for example, on tools. So if you click on tools, you then get the two tools, get alerts and get forecast, right? And we have also a nice description that's essentially taken from the comment that we have under the function definition in our MCP server. So for example, if we click on get alerts, we can here type in NY in the state section, and we can click on run tools. So I've done this already for you. We had a success in this case, and you get the entire response here. So let me actually make this response a little bit bigger, and you can see, okay, in New York, we have a freeze warning. The area is, for example, Hudson, etc. Right, and then there's here a severity, a description, what, where, when, and impacts. Right, so this is essentially the data that's returned from the MCP server that an Claude can take, right, in order to give you a nicely formatted answer. Yeah, and that's already about it. I hope this was informative. And Lee, any questions?
Yeah, I mean, thank you. No, I have never looked like so deep into MCP, like this, like all this like discussions on Twitter, but I never like tried myself on coding my own MCP tool. So going back to your previous slides, my first question is, what's the actual output of the MCP2? Does it has to be text, or it can also be images? Because I have seen on Twitter, like people saying, "Oh, now like I can develop this tool where it compiles my code, runs in browser, and then sharing the screenshot with cursor." But I'm not too sure whether like how that's achieved. Basically, I guess it can be anything.
I don't think there's any exactly. So it really depends on the capabilities of your model, right? If you have a multimodal model, you can input text tokens, you can input audio tokens, you can input image tokens. So I don't think there's any particular limitation really, right?
Right. I see. I see. So the tool can just like return whatever.
It all depends on the capabilities of your LLM, right? That ingests the output of the server. I mean, of the database that you're querying. Yeah.
I mean, theoretically, yes. On high level, I agree with you. Sounds like I mean, it must be possible, but I mean, from the engineering side, because you were like sharing this like UV command, right, and you're running a server, I can see how easy it is if you just return, like a text, right, back to the server. But if it's actually like an image or video, I'm actually not too sure how, like from an engineering perspective, how that's achieved. Can also be like some, I don't know, yeah. Yeah, I mean, there must be a way. So it's probably engineering details, which doesn't matter too much. The other thing I wanted to ask was you are doing some like special formatting, right? Once you received the HTTP request from this weather.gov website, right? Do you think that's necessary? Probably we can just like return all the data to cloud, right? It should also be able to generate the answer for you.
I think so too, right? If you're not too, if you don't want to be too strict on what the model will be presenting to the user, right? Then it should be really flexible. I guess if you want to have a little bit more consistency among different LLMs that query this particular MCP server, then it's good to be more explicit, right? As the server is, but I don't think there's any right or wrong answer. That's a good.
Right. The other two things like I was thinking about when you were doing the demo, the first thing was if the server is like down, what's gonna happen? Probably cloud will be able to understand, oh, something's wrong with this like tool, and then I can call some other tool, right? I guess
Absolutely.
that's
Yeah, we do have these error messages, right? Like no data received. I think even the helper function that queries so if the server's down, the helper function will not return anything. I think there was also I think we had an error code there as well. Let me quickly double check. Under an exception, return none. That's not ideal. So there should be probably something a bit more. Yeah, I mean, error handling and edge cases are always the tricky parts, right? So that can be improved. Absolutely.
I mean, it would be cool that somehow. I mean, it must be probably it's already there. Like after you get the result, you do some like reasoning, right? Whether the result makes sense or not. And if not, you should be querying like more data from some other tools.
Right.
But
I mean,
yeah.
as long as the model has multiple sources, right, that it can select from, and this is what you ingest at the beginning in the context, right? So what's the weather in Sacramento? Here, I'm not sure if it's the system prompt or some added context, right? That we, for example, add if we add a PDF, that's just added context that we paste in. The model somehow needs to understand, right, how to query these things. And if it has multiple choices, then it can learn, or it can just do it, I guess, without even learning. Yeah, just during inference.
Nice. Maybe I should search later, right? After this like conversation, like there must be some like ranking website showing how popular the tools are and what's the biggest use case at the moment. I feel it's gonna be quite interesting to understand how useful this MCP actually is, right? It should be useful in some cases, I can see, but just want to understand if there's any creative ways to use it.
Right.
Yeah.
No, this is. I think it's quite an interesting standard. Also, I mean, look in the. I don't want to make too many analogies in the blockchain domain, but in the blockchain domain you have these token standards, right? ERC20, which is a fungible token, ERC721, which is a non-fungible token. Everybody's just adopting these token standards, and we don't have any centralized entity in blockchains. In AI, we don't have any centralized entity either. But still, somehow the community is really like rallying around the standard, and I think this general consensus among the community is extremely powerful, right? And lowering the frictions with a USB-C standard, right, that everybody adopts, nobody needs to be forced to adopt. It's great.
Yeah. Right. Yeah, makes sense. Yeah. Nice.
we should chat also about maybe. So actually, it would be amazing if you could discuss a bit block GPT. Can also be next time or the other time, right? If you want to present the latest results, I think this can be really exciting for the audience.
It's
But
probably better, right, if I prepare some slides,
right,
because it's gonna be a bit abstract if I just like talk
right,
about it now. No, so
yeah, exactly. Yes, yes, yeah, yeah. It's pretty cool. So how's life otherwise? So I guess it's getting a bit winterish in Sydney. Oh,
no, it's still like very warm, and yeah, the weather is like super nice here in Australia, and my son starts to go to like daycare, right, nowadays. So um, it's a new experience for him, and I mean, he was a bit like scared, or separation anxiety, like oh no, I'm not gonna see my mommy and daddy like for a while, and then just like starts to cry. But yeah,
oh no.
other than that, I mean, like everything's like good, I think. How's life
Yeah.
on your side? Also good.
Oh, I mean, yeah, Europe is amazing in the springtime. No, we have a lot of flowers. Cycling
No.
on the weekend. Oh, yes, true. So last year you were actually in Europe around this time, and this is where things got really, really tough, right? You got
Yeah,
like a
yeah, yeah.
lot of.
I have hay fever, so yeah, it was a horrible experience, but the weather is nice.
It's the best time, Lee. It's the best time.
Yeah, yeah, yeah. Right.
No, everything is great actually. The a lot of people are cycling outside, so the cycling clubs here are very active. Um, yeah, it's there are quite a few people also cycling up the mountains. So I think we're gonna try also on the weekend to do some longer trips, like 100+ kilometers and over 1,000 height meters. So last weekend we went to so there's a city near Andermatt called Göschenen, which is
Mhm.
basically half up the Gotthard Pass. So it's quite nice. Yeah. It's it's a very nice workout, but the way of going there is so pretty, right? Like you have a lot of fields. So I mean, Switzerland in the summer or Europe in the summer in general looks like paradise, right? I find at least. So yeah, quite happy with spending time outside.
Right. Did you buy any new like gears for your like? Did you buy like a new bicycle or something? You probably not. No, you probably didn't.
Uh, not a new bicycle, no. But I did change. So I have a 360-degree camera that I
Right.
put at the back of the bike.
Hmm.
And the funny thing is like it was moving a bit too much, and the thing kind of like went down then onto the wheel,
Oh.
and the lens started to melt because the wheel was rubbing. So luckily, it was actually not the lens that melted, but the lens protector. These are just standard things that you swap anyways because they break from time to time. But interesting. So I have this Insta 360
360.
X4, I think it's
Yeah.
called,
Yeah.
and they have. I mean, they're quite potent. No, 8K camera, 360 degrees view. So later in the app, you can choose where to focus. Right, you have like also automated focus, and then you can export it as a regular 2D video, right? Which is quite cool. It also, you don't have to put it like too far away from you, right? You can have a selfie stick that's like sticking out like this. That's already, it looks wider than it is with the wide camera setup. You can also put it further, then it almost looks like a drone following you, which is quite funny. Yeah. Um, but so far the best setup I've seen, also with other YouTubers, I think it's on the handlebar of the bike. If you put it on the right side, and so it can actually record you as well as the surroundings around you, right? I think that's the safest, because at the back of the saddle, it's a bit, I mean, it may be a bit delicate, and also if you have too many vibrations, right? If you, I mean, I do jump with the bike from time to time. If there's a hole in the street, you have to jump, right? Just gonna hop, right? Then and then obviously the thing could break, which is not ideal. Yeah, you might not even notice until later. So far, I've seen the best setup is really having a clamp onto your handlebar, and then like essentially these GoPro modules. No, you can modify it as you please, how it fits. You could even put like a selfie stick on this as well if you want. Yeah, if it's vibrating too much or oscillating too much, you can change it. Yeah, or fix it. Yeah. Yeah. I mean, I did meet a friend actually on so going down the mountain. I actually when going down, I went a bit too fast. I was like 50 or 60 kilometer per hour, and I met like another colleague, was just going up, but I'm not sure the colleague actually recognized me. It was just looking weird. Yeah. I mean, I had like my winter stuff on, so I was protected, and yeah, maybe not that visible. Big glasses, these bicycle glasses, you almost don't recognize people. So yeah, no, but that's quite cool. Yeah, a lot of people also are discussing about the market swings recently, right? And obviously, I've had quite some people discuss this with me. Yeah, I mean the tariffs are obviously having a huge impact on the global economy, and yeah, otherwise. Yeah, I still have this hanging bar that I use a lot, which is quite cool. Yeah, to just do some upper body work. Yeah, and yeah, right. Hmm. But why is it better? Like, what? How can you have such a feature in better? That's what I don't understand. I mean, it's just yeah, yeah. It sounds super simple. Yeah, yeah. That's why I'm referring to, right? So, like, if the model generation stops, execute, I don't know, open an MP3 file, right? Or like, I mean, that's all. Like, how can this be in better? like many issues. Right. Yeah, I was wondering why. I mean the regarding the song, right, or the tone once a generation finishes. So do you need it because you are in cursor and you're focusing on reading the code and you don't realize that the agent has finished, or is it because you switch to other windows? Okay, so it's okay. Hmm. Yeah, that's quite interesting. I mean I do miss when it finishes, mostly because I'm actually in other windows, which I probably shouldn't be. I should be remain focused, right, on the app. And I also think like just following what the agent does helps you to better understand what it does, and then you understand quickly. So you should not stray, right? The attention should remain actually on the. I think that's the most efficient, at least what I've seen. But ideally, I don't know, really, but I guess there are also some other AI agents that take some longer time. They should just send me a Slack message. No, I'm done. Can you check? like, like, I mean, it's not that complicated. I mean, like this feature, ring a tone. We should just have like a whatever a command that you can run, like a shell script you can run or something, right? Arbitrary command actually. And it can be a tone, but it can also be anything, right? Are you sure? So many. Come back to me later in 2 hours, no, with the result. Yeah. So regarding multiple agents, I mean, I did notice you can interrupt the agent and you can tell it, oh, while it's working, right? You can still. This is super cool. You can while the agent is working, because you can tell it, oh, by the way, this I would like you to do in this way instead. And I did this the other day, I think yesterday or so, and the model, the model, and I saw the thinking, and it said the user wants me to do this, but I should still prioritize the original thing and focus. Exactly. This was so good. I loved it. Like I want models to be more bossy, right? I want models to actually push back, right? Because then I can learn better, and we can come to, if everybody thinks the same, we're just like sheep. I've keep saying this to my PhD students. I mean, I find Gemini is one of the first models who is actually like pushing back, right? It actually questions whatever you give it, and this is I really feel that it's definitely smarter than others. However, Gemini doesn't work well for me in Cursor so far. I don't know. It just like stops. Like there's literally, I will do this now, and then literally the thing stops, and I have to say, yeah, go on, and then it goes on, but it stops again somehow later at some random point. So there was a new version today that came about from of Cursor. I haven't tested whether it fixed the bug. Did you update today? I got an update today. Okay. I think we're not the only ones not having these issues, so I hope they can fix this. The modern. Oh, Cursor. But why? I mean, how? Okay. Interesting. I love Gemini. I mean, this huge context is really cool. But especially this critical thinking. I think this is the first model. Okay, I mean, Grok is great, to be honest. Like on the if I just use it for like general questions or maybe even design questions, right? Grok is great. But Gemini has this little like sprinkle of geniusness, which is really cool. Yeah, yeah, yeah. We can check now the. Yeah, absolutely. I do use it. My standard. So in the browser you have the address bar. The address bar can be either you put in a URL or you put in a search query. My search query doesn't go to Google anymore. It goes to ChatGPT at the moment directly. So that means there's much more friction now to use Google as well for me. And if I want to use Google, I have to type Google first and then ask the query, which I do. I still do, probably on a daily basis, but just much less than before. Yeah. Yes, I use a Super Whisper, and I have some key combinations. I think it's Option Space on the Mac, which allows you to. It's essentially like a pop-up. Then whatever you speak is being translated to text. And when you're done, you can, I think, hit the same combination again or escape. I forgot. And it will just paste it into wherever your cursor at the moment is. Really good. If I use it, I would say I use it roughly 50% of the time. So 50% of the time I'm speaking, and 50% of the time I'm still writing, because I find it much more efficient for short sequences of text. Right, you just want to type quickly. And if it's beyond a sentence, maybe a sentence and a half or two, that's where my threshold is for, okay, now I prefer to actually speak. Which I did actually even do on Slack sometimes. And yeah, I mean, I notice on Slack sometimes I can have miscommunications with people because I'm not explicit enough. And if I would talk to them in an office setting, then it would just be much more clear. So why don't I just use text to speech to just speech to text to just transcribe it? Or I mean, obviously you can send a voice message, but that's then for really long things. So I think, yeah. So it's short text you type, one sentence plus you speak. Let's say 5 sentence or 5 sentence plus you actually record the voice. I think that's roughly my preference. So scientific, no? I give you a lot of quantification. You cannot complain. But I mean, that's what vibe coding is about, right? You don't even look at the code. Rare. I mean, what I do notice is, I mean, maybe I haven't tried enough, but I do notice that in the vibe coding, like if you do vibe code, I do think I should emphasize more tests, write more tests, or ask. I mean, not myself, but ask the LLM to actually write tests. The problem is tests can be very complicated, right? If you make them very realistic. So you don't want too overly complicated tests. So if you do write, I don't know, a few hundred lines of code, then you probably have to mock some, like a database, maybe some user, some login, right? You don't want to test like literally everything in every test. Then the code would be just like humongous, right? But I do think that if you force the LLM to actually write the tests, and then the implementation, or first the implementation and then tests, I guess doesn't matter too much. You will have kind of like two images of what you want to have. And then the LLM will also see, are there any discrepancies between these two, right? And that's where I think the vibe coding can have a lower error rate. And you can also ask the LLM, just walk me through the tests now. Just talk to me. Tell me which tests you have, right? You don't even look at the code. You just ask it. And then you can discuss the tests, and then you will understand whether, or maybe the LM will even understand whether it did what you wanted. Because just talking on the phone, I mean, it's typically not as explicit as a full specification that you write, right? Yeah, right. Yeah, I'm sure. Yeah, yeah, that's true. There's not yet enough critical thinking. Yeah, exactly. But that's why I feel Gemini is getting there somehow. but I haven't tested enough. Maybe I need to, like, with your specific example of like tests, right? Yeah. Fantastically, we're gonna wrap up. Thanks so much for being here, no, and see you next time. Bye.